cover current, current density, drift velocity, resistance, Ohm's law, and variation of temperature with resistance. Small theoretical revision we'll do, and then we'll do the numericals which have come. Mostly we'll focus on the previous year questions that have come. All right, so you all are done with the class 12. So some things you are going to tell me. So current, starting with current. So what is current? It's the rate of flow of charge through any conductor, right? And when you take the cross-sectional area, whatever is the amount of charge flowing, we say that's the rate of charge. Right, so what's the formula? Current, you know, it is dq over dt, right? And when you have to calculate the average current, you will take the change in charge by change in time. Yeah. I hope my screen is visible to all of you.
Yes, ma'am.
All right. So amperes is the SI unit of it, and the magnitude, the current has a magnitude as well as direction. So is it a vector or a scalar quantity? Yes, it has magnitude as well as direction. Is it a scalar or a vector? Yes, class, what do you think? See, it's actually a scalar quantity. Okay, current is a scalar quantity, so you are going to use the simple algebra for it. You need not apply the vector laws for it. Okay. And the second important thing that comes after current is current density. What is current density? Current density is current per unit area of the cross section. So this is represented by J. So current per unit area. All right. So this is the formula that we use. And more importantly, in your JEE exam, what all questions come? They come from the formula where the current is variable, or more than the current, the area is variable. So that time you can use the formula J dot dA, integral of J dot dA. This often is used in the numericals. So I'll show you a question where this is applied, because see, this you will be able to manage. And class, if you have to write anything, if you want to write anything from this portion, just stop me there, then and there. I'll allow you to write. Okay, I'll give you time to write, because these things are already with you. The notes are with you, so I'm not focusing on that. Okay. So this first question says that the current density through a cylindrical conductor, this is given as J is equal to KR. So it's variable. So we know that out of both the formula which we have to apply, the second one, the variable one, where R is the distance from the axis of the cylinder and K is a positive constant. Now the current is flowing parallel to the axis. Figure is also given. If the radius of cylinder is capital R, what we have to find? We have to find the current flowing through the cross section. See, in this question, this is the figure which is given. So let us assume, let us see the separation from the center is some R. Okay, this is the separation. And let's say dr is some thickness. Now, what was the formula? Formula was I is equal to J dot dA integral. So we require two things. We require the current density and we require dA, that is the change in area. Now current density is already provided in the question. What's the current density given? KR, right? So this J is given as KR. This is not an issue. We have to write the area. Then this question is very simple. See how we have to write the area. Let's say we have taken this separation. This separation is having some r, small r. Okay. Capital R is the radius of the cylinder. We'll substitute it later. Right now, we are just taking, let's say some thickness is dr, and the radius of this segment that we have taken is smaller. So when you have to calculate the volume or area of a cylinder, we can use this circumference part. So see, how will we calculate the area? R is the, I'm telling you, R is the radius, dr is the thickness. Can you think of the area? Area of the cylinder, how do we write? Okay, what's the area of a circle?
Pi r square.
Pi r square. What's the circumference of a circle?
2 pi r.
2 pi. So see, when you have to calculate the area, remember what you do, you take the circumference. This is, I'm telling you, for a cylinder. Take the circumference and multiply it with the thickness. Suppose this is the circumference of a circle and this much is the thickness of it. So when I multiply, I'll get the area. If you have to calculate the volume, you take the area and multiply it with thickness. Okay, but right now we require area. So for area, what we can do? Take the circumference. Circumference, as Meera rightly said, this is 2 pi r. Now multiply to the height. What's the thickness that we have chosen? dr. So we have the area. See, what is this dA? This is 2 pi small r dr. Now this is just integration that is there. See, what will be the current? I is equal to, let's put the value, kr. Instead of dA, I'll write 2 pi r dr. And from where do we have to integrate? From the center of the cylinder to the radius, because actual radius we have to calculate, right? We have to find it till the actual radius, the current. Right, so this is simple integration. See, k 2 pi, these are constant terms. K 2 pi, these are constant terms. So these will be taken out, k and 2 pi. R into R will give R square dr integral from 0 to capital R. Now what will be the integral of this? K 2 pi, yes, R square we can write this as R cube divided by 3 from 0 to capital R. Let's put the values. This will be k 2 pi by 3. Here this will be r cube minus 0 cube. We put the upper limit first, then the lower limit. So what's the final answer? Answer is 2 pi by 3 k r cube. Is it clear, this question?
Yes, ma'am. Clear, ma'am.
Okay. Questions you need to write down. Okay, please write down this and just update me. Then I'll continue further. Done?
Yes, ma'am.
And Sana, you've also written?
Yes, ma'am.
Let's continue then. See, now drift velocity. So what is meant by drift velocity? So free electrons of conductor, they are moving with high speed because of thermal energy. So what's the speed? Around 10 to the power 5 meter per second. So when there is no electric field, the average velocity is zero. Okay. But as soon as the electric field is present, in the presence of electric field, electrons all align, they are drifted towards the positive terminal of the battery in the opposite direction of electric field, right? And this speed is called as the drift velocity. So there's a relationship between current and drift velocity. Please tell me what's the relation? Current and drift velocity. You must have used it in your board exams also.
I is equal to NEED. NEED.
Yes. I is equal to NEABD. This is a formula that is used, and sometimes current density is also asked. Current density is C, current divided by area. So current is NEABD. So divided by the area, this will be NEBD. All right, so this you already know. Now sometimes the question come, you have a non-uniform figure, means the area is different, one is wider, other diameter is narrower. What all things you have to compare? The currents, the current density, and the drift velocities. So see, current never changes. See, whatever is the amount of charge which is entering through one end, that will only be exiting through the other end. So your current will remain the same. When we talk about the current, I1 will be equal to I2, whether the area is different, the volume is changing or anything. Now regarding current density, what do you think? What should be the answer? If area is different, see, I'll just mention, we know that A1 is greater than A2 according to the figure, right? This is what we can conclude. So what do you think? J1 is greater than J2 or J2 is greater than J1?
J2 is greater than J1.
J2 is current density is inversely proportional to area. So definitely J2 will be greater than J1. And what about the drift velocities? From this relation, it's very easy to figure this thing. Same. See, this is drift velocity is also inversely proportional to the area of the cross section. So the drift velocity, that is V2, will be greater than V1. All right. Just make this figure, write down this also. Then we'll start with resistance and resistivity. Done?
Yes, ma'am.
Yes, ma'am.
Okay. Now resistance and resistivity. See, what all things are important for from your JEE perspective that I'm going to tell you. The rest of the basic definition, the basic formula, you already know. You already have this with you. See, sometimes the questions are asked where the densities, the resistivities are given of different material and the resistivities are compared. So one thing you should remember, resistance definitely depends upon temperature. That we'll see later. It's a whole theory. But resistivity depends only on the material, right? So when you have the when you are talking about resistivity, this is like density. If you have water, the density of water everywhere will remain the same. So when we're talking about resistivity, this does not depend on length, because you have questions where variations with length will be given and you will be asked to compare the resistances and resistivities. So for that, you should know that the resistance will definitely change, but the resistivity won't change. So this doesn't depend upon the length. It depends on material and the temperature. For a material, for two different materials, resistivity can be different. Now, one formula you need to remember is many questions are asked where the length is changed or the resistance is changed and the other quantity is asked. So R is directly proportional to L square. So two questions have come. In one question, the length was doubled. Okay, there was a question in your 2019 paper where the new length was doubled. So the question was asked from the resistance part, that what will be the resistance. So see, if length is getting doubled, the resistance will become 4 times. Using this relation, you can figure this. And one more question came where the length was increasing. Now, this I'll tell you. First, this is clear that whenever R is directly proportional to L square. Your length is increasing, you square it, you will get the variation with resistance. This is clear?
Yes, ma'am.
Okay. Now, this formula you must have used. R is equal to rho L by A. So this formula is utilized in most of the questions. 3 figures I'll tell you, which have come directly. So it's better you remember it. 2 concentric spheres were there, and one has the radius A, the inner one, the lesser one, and the other one, outer one, has the radius B. So when you calculate the resistance is rho by 4 pi, 1 minus A by minus 1 by B. Okay, this is for the concentric spheres. And if these are concentric cylinders having inner radius small a, outer radius as B, so the formula will be rho by 2 pi L log B by A. All right. So this cylindrical part has directly come in the exam. Sphere can come, so you should remember this. Now, one more thing, class. If this figure comes, if this figure comes, let's say this radius is A and this radius is B. So here the formula will be R is equal to rho L by pi A into B. Okay. Now see, if this is uniform, this is a cylinder. Let's say this is a cylinder, this is uniform. So in that case, A and B will be equal. So what will be the formula then? Rho L by pi A square, rho L by A. We are getting the formula back. Right, rho L by pi A square it would be, because B will be equal to A if it's a symmetrical cylinder, right? So R is equal to rho L by pi A square will be the formula. And what is pi A square? It's the area. So we are getting the actual formula back. So if this is variable, both the radii that are present on the extremities, they are variable. So what you can use the formula rho L by pi A into B, multiply both the radii. Okay. And for concentric cylinder, you can use this. For concentric spheres, you can use this. Regarding the length portion, that I'll tell you later. This we'll see through questions. Okay, coming to the resistivity, M by NE square tau, this is the formula. And you have variation with resistance. 2 graphs you need to remember. Now, this was there in your CBSE board exams also. So tell me, which material is this where the resistivity is directly proportional to temperature? Which material is this?
Conductor metal.
Yes, this is a conductor. So when the temperature increases, the resistivity increases. What about this? Which material is this?
Semiconductor.
Yes, semiconductor. See, these are semiconductors and sometimes these are used for the insulators also. Okay, so these are the semiconductors or insulators also. It's just that the graph will become steep. Okay, so these materials you need to identify. Now, regarding the resistivities variation and resistances variation. So resistivities are this rho is representing resistivity. Rho is equal to rho naught 1 plus alpha delta T. R is equal to R naught 1 plus alpha delta T. What are these rho and R? These are the resistivities or resistances at certain temperature. Delta T is the change in temperature. Alpha is the coefficient of resistance here, and here coefficient of resistivity. Now lots of questions have come from this topic. What you need to know regarding some details regarding this coefficient of resistance. Okay, this coefficient you need to know. When is it positive? So for conductors, the first graph which we have seen, which you were mentioning. So for conductors, the value of alpha is positive and the value of alpha is negative for semiconductors or the insulators. So this you need to know. Now, from this basic formula, you can get the value of this alpha as R2 minus R1 divided by R1, T2 minus T1. Questions have come from this also. Now, very important things that you have is if they are connected, we are having two wires, they are connected in series. The resistances are mentioned, the coefficients are mentioned, and the equivalent coefficient is asked. So remember these two formula. Equivalent, alpha equivalent in series will be R1 alpha 1 plus R2 alpha 2 divided by R1 plus R2. Means 1 1 together, 2 2 together. Alpha 1 R1 together, R2 alpha 2 together. But if the same connection is made in parallel, what you do, just interchange these two. R2 into alpha 1 plus R1 into alpha 2 divided by R1 plus R2. Is it clear till here?
Yes, ma'am.
Okay. Regarding Ohm's law. So see, then we'll start directly with the numericals. So Ohm's law, you know what's Ohm's law? Potential is directly proportional to the current, and provided that the temperature remains constant, the pressure remains constant. So your formula V is equal to IR is valid everywhere. This is valid. You should remember the microscopic form of Ohm's law. That is the current density is equal to the conductivity into the electric field. What is conductivity? Inverse of the resistivity, right? And sometimes the questions have been asked from mobility. Mobility is the drift velocity per unit electric field. So what kind of questions have come from mobility? Variations of drift velocities are mentioned. You can use the formula I is equal to NEA VD. From this, you will calculate the value of VD and then put it here and then get the value of mobility. These questions are asked. All right. So I think from this topic, this portion, just write down this formula and the cylindrical and spherical one. I think the rest of the things you must be having already. Then we'll start with the numericals. Okay, just write down these two. And write down these two also. This has directly come in the exam also. Done?
Yes, ma'am.
Yes, ma'am.
And I think you should write these two also. Okay. Series and parallel formula. This is very important. We'll discuss a question also based on this. Yes, class, done?
Yes, ma'am.
Okay.
Yes, ma'am.
Let's start with the numericals then. Okay, rest of the things, I think you need not write anything else. You must be having the rest of the formula with you. These are from the board's perspective only. The rest of the extra portions, I think you have written. Okay. See, so this is a question from your 2022. The current density in a cylindrical wire of radius 4 millimeter, it's given. Value of J is given. The current through the outer portion of the wire between the radial distance R by 2 and RS means this is a concentric cylinder. Okay. Now, right now, the resistance is not asked that we are going to use the formula for the resistance. We are here, the current is asked. Current density is given. So when current and current densities are present, we straight away use the formula I is equal to current density multiplied to the area, right? Now, what's the current density? It's given as 4 into 10 to the power 6. Regarding the area, see, when we are talking, this is like, this is a cylinder and there's a concentric. Concentric means inside this, you are having a cylinder as well. And this portion's current density is asked. So what we need? We want this area only. When we are calculating the current density, we require this much area only. So what will it be? See, this will be J into current. This will be pi R1 square minus R2 square. Pi R square will be pi R1 square minus pi R2 square. Let's just write down the values. See, this will be, this is 4 into 10 to the power 6. This is pi. Let's put it as pi only. Later you can calculate. R1, this will be R square minus, second one is R by 2. So that will become R square by 4. What is the radius given? 4 millimeter, right? So let's put the values of radius also. So here, see, 3R square minus, see, when you take the LCM here, this will become, this is 4, this will become 4R square minus R square, right? So this will become 3R square by 4. So let's put this. Current will be 4 into 10 to the power 6. 3 by 4 pi R square. R square is 4 into 10 to the power minus 3 because it is given as millimeters, right? This much whole square. So this is our J pi R1 minus R2 whole square. Is this question clear?
Yes, ma'am.
Okay. The
Yes,
calculation is very easy. Quickly tell me what's the answer. I'll tell you the correct one. But yeah, first write down this question. Please write this, then I'll tell you the correct answer. Whatever answer you're getting, just text me in the chat column. Yes, answers. Yes, you can leave the answer in terms of pi. Okay, leave the answer in terms of pi. Yes, 48 pi, correct. See, you'll get the answer as 48 pi. Okay, let's move to the next question. So this is from your 2019 means, okay? From the 9th Jan paper this is taken. So this is a very easy question. Please try to answer this. This says that drift speed of electrons when 1.5 amperes of current. What's the value of current that is given? 1.5, right? This flows in a copper wire of cross section 5 millimeter square is V. So area is given. What all things we have? Area is given, current is given, and drift speed, this is put as V. So if the electron density in copper is 9 into 10 to the power 28, number density of electron N also we have, the value of V in millimeter per second. See, remember, whenever you have drift velocity, the unit for drift velocity is chosen mostly as millimeter per second or centimeter per second. So we have to find out the value of this drift velocity. So what's the relation we should start with? What's the formula you think we should apply?
Current is equal to NE in AV.
I is equal to NEA VD. Okay, current is I is equal to NEA VD. Here, see, drift velocity is missing. I think rest of the things are given to us. What's the value of current? Current is 1.5. Number density, this is 9 into 10 to the power 28. Yes, E. What should I put it as E? E is not mentioned. Then
1.67.
electronic charge.
10 power.
So this is yes, 1.6 into 10 to the power minus 19. Now area is also given 5 millimeter square. So see, millimeter square we need to convert. This will be 10 to the power minus 6 because square of 3 means you're multiplying 3 with 2, 10 to the power minus 6 into VD. Now tell me what's the value of VD you're getting. Okay, I'll tell you the answer. Write down this, then we'll start with the next question. As you get the answer, you can type in the chat box. Okay, what I'll do, let me give you the options. You tell me the option only, because the options from this question only I'll tell you. A, B, C, D, all the four parts. Because the options are put very close to each other. So you both just tell me which option of yours is matching. These were the options associated with this question. I think Upsana, your option C is there, and Mira's option A, right? It's option A actually. Okay, 0.02. The answer will be 0.02 millimeter per second. Just check the calculations. Some error must be there only. Let's move to the next question. Now, the next question is the one which I was mentioning to you when we were discussing the resistance part. So the options are there. First, you try it by yourself, but very quickly. Okay. Tell me which option is matching. This is a question from your 2019 mains. Like this question should just take, actually it should just take 10 seconds to solve once you know the method. But okay, fine. Tell me whichever option is getting matched. See, this question shouldn't take this much long. If you go by the entire method that the volume is remaining constant, then you'll take area into length. A1, L1 is equal to A2, L2. See, right now you just need the final answer. You need not show the steps. So what you can do, I told you resistance is, how is resistance related with length? I told you a relation. How is it related?
Proportional
L
to
square, directly proportional to L square.
Very good. R is directly proportional to L squared. So what you do, you have studied error analysis in your class 11th. You apply that concept. See, when we have error analysis and when we write the equation in the fraction form, we write this as change in the resistance by original resistance equal to, whenever the power is present, power gets multiplied, delta L by L. If you remember, you must have done this in your error analysis, units and dimension. Is it clear, this part?
Yes, ma'am.
Okay. So
Yes,
whenever
ma'am.
you have the equations, do it in this manner. If you have to find out the change, percentage change in fraction. So this is very easy. Now, what is the percentage? For the percentage, we need to multiply it with 100. Right. So 100 will be on this side also for the resistance. change, and 100 will be on this side also for the resistance change. I'll write it like this. 2 multiply to delta L by L. Now look it like this. Percentage change in resistance is 2 times the percentage change in the length. That's it. Percentage change in the resistance will be 2 times the percentage change in length. Means if the length is getting 0.5% longer, you multiply it with 2. Which option is right then?
B.
B, 1%. So when you know this already, you will just double it, right? So if this relation, when you are using this, R is equal to L square, the condition is that volume should remain unchanged. And in the question, it has clearly mentioned that the volume remains unchanged. So what we are going to do for the percentage change, see if the percentage change in length is 0.5%, you will double this, the percentage change in the resistance. This will become 2 into 0.5, that is 1%. So option B will be right. So this will just take 10 seconds when you know the equation. Okay. Write this. We'll then move on to the 6th question. Is it clear till here? Are you guys able to understand till here? It's fine?
Yes,
Yes.
ma'am.
Write it. Upsana, it's clear to you too?
Yes.
Okay, please write this. Last written?
Yes,
Yes.
ma'am.
Okay. The next question. Okay, this is the question. The graph is mentioned. All the options are given. Again, this is from your variation of resistance with temperature. So this says in an experiment, resistance of a material is plotted as a function of temperature. This graph was obtained and it's a straight line we can see. One of the conclusions out of this is correct. So this is a question from your 2019 only, shift 1. So just write down this question first. Take 2 minutes. Tell me which option according to you is right. See, we are going to use the formula only. R is equal to R naught 1 plus alpha delta T. But how are we going to connect it with this? This looks very difficult, but actually it's just your mathematics only. So anyways, first write down this. Just text me done once you are written. Once you have written, then we'll discuss this. Have you written, both of you?
Yes, ma'am.
Okay.
Yes, ma'am.
Any answers? Anything, any answer you're getting? No? Let's discuss then. See, this is just a simple mathematical question. Just take it as a mathematical question. You will just relate on things. See, let's say this is touching at some ln r naught. Okay, this is touching at some ln r naught. So when we take, this is a straight line. So the question, by stating the term straight line, this is mentioning if it's a straight line, you have to use the equation of a straight line. Mathematically, we have the equation of a straight line. So your ln r, which you are calculating, this will be, see, this is negative slope. So we'll take minus m. Okay, since it's a negative slope, we'll take this as minus m. Now x minus mx, what's there on the x-axis? We have 1 by t square, right? So this is 1 by t square. So mx plus, what do we write? C, which is the intercept. What is the intercept that I have taken? Let's say ln r naught. Now we have at least satisfied the equation. Why? Because question mein to straight line mentioned hai. Question is straight away saying that this is a straight line that has been mentioned. So you are also going to use the equation of the straight line. Ln r is equal to minus m into 1 by t square plus ln r. Now, if I bring this ln r naught here, ln r minus ln r naught, this is equal to minus m by t square. What is log a minus b? कैसे लिखते हैं log a minus b को?
A by B.
Log
Yes,
or baby.
log a by b, correct. So this is written as ln r by r naught, which is equal to minus m by t square. Now, if you have to replace this log, what does come? Exponential. So see, that's why these options are given in this manner. Exponential mentioned यहाँ पे. So if I remove this log sign, this will be r will be equal to c. When the r naught will go here, how will I remove the log? Exponent will come and the rest of the thing goes into the power of the exponent, right? So power of exponent will have minus m by t square. That's it. This is what we could conclude till here. Further, अब ये आगे solve नहीं, right? So how are we going to relate with all the options that are given? See, RT is equal to R naught E to the power T square by T naught square. Firstly, we have in the denominator, we have T square. So this is invalid. Also minus sign is also not there. So this is incorrect. This doesn't have the exponential. So is it right or wrong? The exponential is not there. E is not present here. We are getting E. So this should be cut, right? Yeah. Now, out of these two, we are left. See, both of them are giving us a sense. Minus is also there. But see, how will we choose? T square is coming in the denominator of the power. T square is coming in the denominator of the power. So this will also be invalid. Answer is option D. So more than your physics, this was a question from your maths, but you need to just match on the things. Okay, whatever you are getting, you need to match on with the options. Have you understood this question?
Yes, ma'am.
Okay. Just quickly write the solution. Question you have already written, write the solution, then we'll see some other question.
Done, ma'am.
All right, so this is now question 7 from 2015 mains paper. So a little old question. This says when 5-volt potential difference is applied across a wire of length 0.1 meters, the drift speed of electrons is 2.5 into 10 to the power minus 4 meter per second. If the electron density in the wire is given 8 into 10 to the power 28 per meter cube, the resistivity of the material is asked. See, the terms that are given are very simple. What all things we have? We have the potential, 5 volt. We have the length of the wire as 0.1 meters. Drift speed, drift velocity, this is given as 2.5 into 10 to the power minus 4 meter per second is given. Just a second. Yeah. So drift velocity is given as 2.5 into 10 to the power minus 4. And what all we have? We have the value of n. 8 into 10 to the power 28. Okay. And what do we need to get? We need to get what is resistivity. So what do you think? How should we proceed with this? All the values that are provided in the question, I have written it. By looking at this, what do you think? How should we proceed? Yes, Meera? Meera, you tell. कैसे कैसे start करना चाहिए question? At least
Ma'am,
tell one
should
or
we
two steps. Yes, Meera?
first find the current?
Yes.
Should we first find the current?
Yes, very good. See, this is simply asking us to utilize Ohm's law. V is equal to I R. Now, resistivity is asked, not resistance. So we can write resistance as rho L by A. We have L, we have A. Rho is asked, what is the current? Current's relation with drift velocity, you already know, which is NEAVD. And the potential, that is the value of potential, is also given. See, when we put area will automatically be cancelled. See, if you put it here, V will be equal to NEAVD into rho L by A. So area will be cancelled. From here, rho is asked. So what will rho be equal to? Rho will be V divided by NEVD into L, right? NEVD into L. So let's put the values. The resistivity is equal to 5 by, what's the value given? N, 8 into 10 to the power 28. 1.6 into 10 to the power minus 19. Drift velocity is 2.5 into 10 to the power minus 4 meter per second. And length is 0.1 meters. This much. What's the SI unit? What's the SI unit of resistivity? Upsana?
Ohm meter.
Ohm meter. Yes. I'll give you the options. Just tell me what's the answer you're getting. I'll tell you all the 4 options. Just tell me which option you're getting it right, because it will help you solve it, because all the options are very close to each other. So you just need to take the powers of 10 and check. This much ohm meter. 1.6 into 10 to the power minus 7 ohm meter. 1.6 into 1.6 into 10 to the power minus 5 ohm meter, and D part is 1.6 into 10 to the power minus 6 ohm meter. These are the options that were there in this question. So value, it will be close. You just have to be careful with the powers of 10. Write down this and tell me what's the answer you get. Question also you have not written, no? Write the question. Yes, any option which is matching? Or you're solving? The answer is 10 to the power minus 5. Okay. Yes, yes. Both of you, I think, have got the correct answer. Yes, option C, right. This is 10 to the power minus 5. Correct. Very good. Let's come to, this question. So, okay, this is a graphical question. This is from your 2022 shift 1, 29 June. So what's there in this question? This says that the variation of applied potential and current flowing through a given wire is shown in the figure. Where is the figure? This is the graph that we have. Okay, variation of potential versus current is given. Then it is saying length of the wire is 31.4 centimeters. It's saying diameter of the wire is 2.4 centimeters. So length is given, diameter is given. And then it is saying resistivity is some x into 10 to the power minus 3 ohm centimeter. What is this value of x? How will we start? Take pi as 3.14. This was a part of the question only. Yeah, this is the graph which is given. This is the potential, this is the current, and this is the value of resistivity. So you basically need to calculate the value of resistivity. Okay. So write down this question first. Just text me done, then I'll show you the graph also. See how we have to solve this question. By looking at the graph, see, the graph is between V and I. What does the slope of this graph give you?
Resistance.
Resistance. The slope of the graph gives us resistance, right? So at least we know using this we can get resistance. And resistance and resistivity have a relation. When length is given, see, length and diameter, these are the two things that are provided in the question. Length is there and diameter is there. So yes, how are resistance and resistivity related? Which formula is applicable?
R is equal to rho L by A.
Yes, very good. R
Rho
is
L
equal
by
to
A.
rho L by A. Yes. So looking at the graph, see, the slope of the graph, slope is always given with tan theta. Right now, our slope is equal to the resistance. So what is the value of resistance? The value of resistance is tan 45 degrees. This is 1, means the value of resistance is 1. And now you can connect. Resistance is rho L by A. For A, we have the diameter, that is pi r square. Now r is what? D by 2 whole square. So you need to calculate the value of resistivity from here, right? So what will the resistivity be? Resistivity will become the resistance, that is 1 only, multiplied to the length. Okay. And multiplied to the area divided by the length. We are calculating the resistivity. So when you're calculating the resistivity, this will be R A divided by L. Now, since area is directly not given, we can use the formula pi d square by 4L. Put in the value, see what's the value of x coming. You have to tell the value of x. Total is already given to you. Tell me what's the value, put the value, tell. This question did not have options. You have to get the value of rho in terms of centimeter only. So don't convert anything, just multiply. See, Written?
Yes, ma'am.
Okay. So I'll tell you the answer. Or did you get any answer right now?
1.44.
How much?
1 point.
0.44. 0.144.
144. Answer is 144. Means total will be 144 into 10 to the power minus 3. Just make sure whatever calculations you are doing, you are shifting the decimal so that you are getting this out of the calculation part. Okay, one question based on the formula of the resistance with temperature. So this says a metallic wire has a resistance of 120 ohm at 20 degrees Celsius. You have to find the temperature at which the resistance of the same metallic wire rises to 240 ohms, where the temperature coefficient of the wire is 2 into 10 to the power minus 40. What do we have to calculate? Temperature. See, both the resistances are mentioned. The resistance at the room temperature, the resistance at the rise in temperature. Both the resistances are mentioned. Now, when we were discussing, I told you this formula also. Alpha is equal to R2 minus R1 divided by R1 into T2 minus T1. Straight away use this formula. Don't derive anything. Straight away use this formula for the coefficient of temperature, coefficient of resistance, right? So see, right now, what is our R2? R2 means that the resistance at the temperature. Okay, resistance at this T temperature, which we do not know, which we have to find out, minus resistance at the room temperature. That is, here it is given as 20. Okay, RT minus R20 divided by R1, that is R20. Now change in temperature means final temperature we don't know. That we need to calculate. T minus, what's the initial temperature given? It's given as 20. So this is equal to alpha. Alpha is given in the question. So this will be, let's put in the values. Alpha is 2 into 10 to the power minus 4. Resistance at the temperature is 240. So 240 minus this is 120 divided by 120 T minus 20. So what do we need to calculate? We have to find out the value of this T. So let's do one thing. Since this is variable, let's bring it here. T minus 20 is equal to 240 minus 120 is 120. Right. Divided by 120 into, which term is that? 2 into 10 to the power minus 4. Right. From here. Now see, this cancels. Okay. So you are just left with 2 into 10 to the power minus 4 with the addition of this 20. Right. 120, 120 will be cancelled. You are left with T will be equal to this 1 by 2 into 10 to the power minus 4 plus this 20. Okay. So 1 by 2, this can be written as 0.5 into 10 to the power 4 plus 20. This will be 5,000. Right? 0.5 into 10 to the power 4 is 5,000 plus 20. What's the answer? 5020 degree Celsius. Am I clear?
Yes, ma'am.
Yes, ma'am.
Okay. Write this, then one last question we'll see, and then we'll end the class. Write down this first.
Done, ma'am.
See, so last question for today. This says two conductors have the same resistance at 0 degrees Celsius, but their temperature coefficients of resistances are alpha 1 and alpha 2. The respective temperature coefficients of their series and parallel combinations are nearly. So see, this is a question from your AIEEE. That time JEE was also not there, 2010. But this question has been repeating itself. This question is a very, very common and a favorite question. So see, if you go by the entire method, how to solve it, if you start with the resistance and you take the series resistance, means you take the equivalent resistance R1 plus R2, and for parallel you take it as 1 by R1 plus 1 by R2, and then you put the values of R1 as 1 plus alpha 1 delta T, like this. So it will be very lengthy for you. You won't have this much time. So what we have, there's an advantage in this question. It says same resistance. And I made you write two formulas specially, series and parallel. Remember in the starting of the class when we were discussing the theory part? Just turn the pages, see, have you written it? Series and parallel for the equivalent thermal coefficients.
Yes.
Yes.
Yes, ma'am.
So use that, straight away use that. अब उसमें series में क्या है? I told you that in series, you have, see, alpha equivalent is alpha 1 R1, same यहाँ पर आएगा. 1 with the 1, alpha 1 R1 plus alpha 2 R2 divided by R1 plus R2. The advantage of this question is that it is saying same resistance. So same resistance means R1, which is equal to R2, is R only. So this, which was supposed to be a very difficult question, is actually very easy. See, if I put the values alpha 1 R plus alpha 2 R divided by R plus R. From here, I'll have R common, alpha 1 plus alpha 2 divided by 2R. 2 gets cancelled and I get alpha 1 plus alpha 2 divided by this is 2. I have cut R. R has cut. So this is for what? This is for series. Now what about parallel? Parallel, I told you, similar formula, but the 1 and 2s are interchanged. So alpha 1 with R2, right? Plus alpha 2 with R1 divided by R1 plus R2. That's it. Now here, will there be any difference in the answer? Because alpha 1 and alpha 2 are the same. The answer which was varying it, that was the resistance. This is same in this case. So अब resistance हमारा same है. What can we put here? Alpha 1 R plus alpha 2 R divided by R1 plus R2. I think it's the similar. Not R1 plus R2, we'll again have 2R only. R plus R will give us 2R. So answer will be alpha 1 plus alpha 2 divided by 2 in case of parallel also. Which option is right? A. Is it clear?
Yes.
Any queries, anything you want to ask from today's class? Meera and Upsana?
No.
Okay. Just write down
No.
this question. So sir will, I think on Saturday, will continue with vectors. He'll be taking the vectors part, and in the next class, then we'll practice. See, in today's class, we focused on these topics only. That's why I didn't go on to the other portions. So from batteries onwards, we'll do it in the next class. The questions will be there pre-written. Just revise this portion, come, revise the 12th portion and come.